Neptune has always been the planet that seemed to hide at the edge of everything. Too distant to shine brightly in the sky, too cold to feel familiar, and too remote for humanity to study in detail. For much of history, it existed only as an unseen possibility. Even after its discovery, it remained mysterious, a deep blue world wrapped in powerful winds, giant storms, dark rings, and one of the strangest moon systems in the solar system. Now, the James Webb Space Telescope has revealed Neptune in a completely new way. But instead of making the planet easier to understand, the observations have made it even more mysterious. Webb detected Neptune's auroras in unexpected regions of the planet. At the same time, it found evidence that the upper atmosphere appears much colder than it was during Voyager 2's visit decades ago. This suggests that one of the solar system's most violent planets may be changing in ways scientists still cannot fully explain. Neptune itself was never an ordinary discovery. Unlike the planets visible to ancient civilizations, Neptune was found because astronomers noticed something unusual. Uranus was not moving exactly as predicted. The only explanation was that another unseen world farther away was influencing it through gravity. So Neptune was discovered first through mathematics and only later through observation. It was a planet revealed by hidden forces before anyone truly saw it. That unusual beginning almost feels symbolic now, because Neptune continues to hide its secrets. The planet orbits around 30 times farther from the Sun than Earth. Sunlight there is roughly 1,000 times weaker than what reaches our world. Neptune takes 165 Earth years to complete a single orbit, meaning humanity has not yet watched it finish one full year since its discovery. Its distance is also why only one spacecraft has ever visited it, Voyager 2 in 1989. Yet even the limited data we have revealed a surprisingly active world. Neptune is classified as an ice giant with an atmosphere rich in hydrogen, helium, and methane. Methane gives the planet its famous blue appearance. But beneath that calm color lies an extremely dynamic environment. The planet hosts some of the fastest winds in the solar system, approaching extreme speeds. Massive dark storms appear and disappear across its atmosphere. Unlike Uranus, Neptune releases significant internal heat, suggesting powerful processes are still active deep inside. Despite its freezing temperatures, Neptune behaves less like a quiet outer world and more like a restless system still driven by hidden energy. Webb's recent observations became especially important because they clearly revealed Neptune's auroras. But unlike Earth, where auroras gather near the poles, Neptune's magnetic field is highly tilted and offset from its rotational axis. Because of this unusual geometry, the auroras appeared around mid-latitudes instead. This immediately highlighted how different Neptune's magnetic environment truly is. Then came the larger mystery. At the same time Webb detected these auroral signatures, it also found that Neptune's upper atmosphere appeared dramatically cooler than measurements taken by Voyager 2 decades earlier. This was not a minor difference. It was significant enough to raise new questions about how Neptune's atmosphere actually works. Auroras are already difficult to observe in colder environments, yet Webb detected them while the upper atmosphere seemed colder than expected. That contradiction deepened the mystery. Neptune receives very little sunlight. Its seasons last around 40 Earth years, and internal heat likely plays a major role in shaping its weather. So if temperatures changed noticeably over only a few decades, what caused it? Could it be seasonal evolution? Internal activity? Magnetic interactions? Atmospheric chemistry? Webb did not answer those questions. It simply showed that they now demand answers. Neptune has always been full of contradictions. It is one of the coldest major planets, with atmospheric temperatures near -201 degrees Celsius, yet it generates enormous storms and extreme winds. Voyager 2 observed the Great Dark Spot, a massive storm system driven by powerful atmospheric motion. Later observations showed such storms appear and disappear over time. Neptune's atmosphere is constantly changing. Scientists believe internal heat may explain part of this activity. Unlike Uranus, Neptune radiates excess energy from its interior, which may help power its violent weather. But that idea creates another mystery. If internal heat drives so much activity, why would the upper atmosphere cool so dramatically? What process changes quickly enough to be noticeable on human timescales on a world that takes 165 years to orbit the Sun? The mystery extends beyond weather. Neptune's magnetic field is one of the strangest among the giant planets. Its unusual tilt changes how charged particles move and where auroras form. This means atmospheric behavior, magnetic interactions, seasonal changes, and internal energy may all be connected in ways scientists still cannot separate clearly. And Neptune's surroundings only make the story stranger. Its rings are dark and dusty, containing unusual arc structures that remain difficult to explain. Its moon system is dominated by Triton, a world that may not even belong there. Triton travels in a retrograde orbit, moving opposite Neptune's rotation. This strongly suggests it was captured long ago, likely originating in the Kuiper belt as a dwarf planet-like object. In a sense, Neptune may have captured an entire world. Triton itself is extraordinary. Its surface appears relatively young, showing signs of ongoing renewal. It contains nitrogen ice, a thin atmosphere, unusual surface markings, and evidence of cryovolcanic activity. Voyager 2 even observed plumes rising above its surface. Some scientists suspect Triton may hide a subsurface ocean beneath its icy crust. So Neptune is not simply a planet with moons. It is a system containing a captured outer solar system world that may preserve clues about the distant past. This is why Webb's discoveries matter so much. Neptune was already mysterious. Now its auroras, atmospheric cooling, magnetic behavior, storms, rings, and moon system all seem connected to deeper questions we still cannot answer. And the challenge is distance. Voyager 2 passed Neptune in 1989. Since then, we have relied mostly on telescopes. No confirmed mission is currently heading there. Reaching Neptune takes more than a decade even with modern technology. That means every unexpected discovery remains unresolved much longer. When Mars surprises us, missions can follow. Jupiter and Saturn have hosted multiple spacecraft. But Neptune remains largely unexplored. It is still the last giant world humanity barely knows firsthand. Webb has reminded us that Neptune did not become simpler with time. It became more mysterious. Its strange auroras, cooling atmosphere, violent storms, tilted magnetic field, dark rings, and captured moon all point toward a system still hiding major secrets. And until humanity returns, those secrets may remain beneath the blue clouds, waiting in the distant cold darkness at the edge of the solar system. If Neptune already feels like an unfinished mystery, there is another question hiding beneath everything scientists have learned so far. What is actually happening inside the planet itself? Because despite all the attention given to its storms, winds, auroras, and moons, Neptune's interior remains one of the least understood structures among the giant planets. We know the planet is not solid like Earth. Beneath its atmosphere lies a vast mantle made of water, ammonia, and methane under immense pressure. But these are not oceans in any normal sense. Deep inside Neptune, matter exists under conditions almost impossible to recreate on Earth. Temperatures climb thousands of degrees. Pressures become millions of times stronger than atmospheric pressure at sea level. And under those conditions, scientists believe something extraordinary may happen. Carbon atoms from methane could be compressed into crystalline structures and sink downward through the mantle. In simple terms, Neptune may literally produce diamonds deep inside. The idea sounds almost fictional, yet laboratory experiments have shown that under extreme pressures similar processes